Welcome and hello. This is a video exercise in MODSIM, and in this exercise, we're going to be dealing with reservoir storage balance. So what that means is we're going to be using custom code to modify the priorities in two different reservoirs, which will indirectly affect the storage in those reservoirs over the course of a simulation. All right, so let's go ahead and get started. What I have on the screen is my MODSIM. So I'm going to sketch the network schematic first, add some data, run the model, and then that will be our baseline for moving forward in a few different scenarios, which will be explored as we add some custom code to our program here. All right, I'm going to start off with a reservoir now. This is going to be called Res1. I'm going to add a second reservoir in parallel. That's going to be called Res2. Downstream of these two reservoirs, I'm going to have a non-storage node, a network sink, and a consumptive demand. So the non-storage node, I'll call that NS1. The demand, that will be called D1. And that is really all I need as far as naming goes. I'm going to go ahead and zoom in a little bit here and reposition my elements. So we're ready to go on data input. Let's talk about reservoirs 1 and 2. These are actually going to be identical reservoirs, at least right now. We'll start them off as the same. So I'm going to edit the properties in reservoir 1. Each reservoir is going to have a 250,000 acre-feet of storage. So in the general tab right here, I'll type in 250,000 for 250,000 acre-feet. That'll be the units. It's going to start full. The initial volume will also be 250,000 acre-feet. And then the priority right here, I'll leave that at 100. One more thing I need to edit is the target. So click on target, and then for the volume, just start that at the target volume will also be 250,000 acre-feet. All right, apply and OK. I'm going to make these same edits to reservoir 2. So right click, properties. On the general tab, I already have 250,000 on my clipboard, so we'll just paste that in for maximum. Initial, and the priority is 100. That's good. And then in the targets tab, we want to set it to full, 250,000 acre-feet of water. All right, so we're done with editing the reservoirs. I also need to add some data for the demand. Down here in D1, I'm going to go right click and properties. The priority for the demand is going to be 50. So here on the general tab, I'm going to change 100 to 50 for the priority number. And then the time series is going to be data I have saved in an Excel file. Yes, right here. Okay. This is going to be data that repeats year after year. Yeah, I also need to change the time step. We'll be with that in just a moment. I'm going to go right click and paste column. So this is a repeating time series data set for the demand at D1. Here's the plot. And it basically shows 5,000 up to 7,000 in the middle of the year, the summertime, and then back down to 5,000. The units are in acre feet per month. It says right down here. And let's go ahead and extend the time period of the simulation to 5 years. So I'm going to go up to MODSIM and then click on Network Settings. And then in this second tab here for time step, I'm going to change the 1981 end date to be 1985, right there, Jan 1, 1985. And then also the simulation end date, it's going to be the same as the data end date, which is January 1, 1985. Okay, so click Apply, click OK, and let me save my model before we actually run it. File and save. Let's navigate to the project directory now. Okay, here is the project directory. I'm going to just call this exercise, what are we on, 26? Now let's think about what's going to happen here. We have a demand that has a higher priority, higher ranking than the storage in these reservoirs. However, these reservoirs both have the same priority. So it's kind of unknown to me as to which reservoir is going to drain first, or perhaps at the same time. But let's go ahead and just run the model. So I'm going to go MODSIM, run MODSIM, and click OK. All right, so that ran. Let's check out the demand here, D1. I assume this will be fully satisfied. So I'm going to change the units to flow, which is right here. And sure enough, over the course of the 5 years, we have a satisfied demand, because if I expand this, the demand right here in orange equals the surface inflow that's being delivered to that demand node D1. Okay, let's take a look at the reservoir data now, specifically the volume. So I'm going to go right click, graph, and then over here, right click, graph. So I'm seeing the data for reservoir 1 and reservoir 2. It looks like reservoir 1 is releasing first. So it's releasing all of its water. It looks like it runs out of water in the middle of the 4th year. And then that's when the reservoir 2 takes over. So there's zero release from reservoir 2 for the first 3.5 years. And then halfway through the 4th year, it starts to release its water. All right, we should see this same reservoir behavior reflected if I click on volume. So here's the volume data in those reservoirs. And let me expand the data here. So here is the actual storage in reservoir 1. It starts releasing right away from 250,000 acre feet. After 3.5 years, it's empty. And then after that time, the storage right here, the dark orange, this is the storage in reservoir 2. Yes, res 2 storage. So it's completely full for the first 3.5 years. And after that period of time, it starts to empty out. All right, cool. So what we're going to do next is run through a number of different scenarios by writing custom VB.NET code, integrating it in with our MODSIM, just to change the behavior of how these reservoirs release water as they serve this downstream demand during this 5-year simulation. All right, so I'm going to close that, go up to File, and then click on Save. Okay, it's already saved. All right, so what I'm going to do is come up to the MODSIM menu, click on Custom Runs. This is going to open up the Custom Run Code Editor. And what I want to do first is change this language to VB.NET. You can write in C# as well, but all the examples are in VB.NET, so that's sort of what I'm happen to be getting used to. All right, and now down here we have our template code where we import a few libraries. Here is our main function, our main module. Here's the main subroutine, and then down below here is where we can insert the code based on the specific event. All right, so for this first scenario, or I guess I'll call this the second scenario, what we already was the first scenario. I'm going to modify the priorities in the reservoir 1 and reservoir 2 such that reservoir 2 will drain first. After that, then reservoir 1 will drain to satisfy the demand. Now, at this point, this isn't something we couldn't just do it through the user interface and the GUI, but it's good to understand how it works in code. Therefore, once the code gets more complicated, then we'll already have a little bit of a head start. Just above this onInitialize subroutine, I'm going to add a couple global variables here for the nodes, the reservoir 1 and reservoir 2 nodes. And then after that, inside the onInitialize subroutine, I've got some code right here. All I'm doing is assigning those two node objects where mres1 is associated with this node res1, and then mres2 is associated with the node labeled res2. All right, so we're not doing anything yet. We're just assigning the variables to those nodes. Next, I need to figure out how to set the priority of the reservoir. So if you don't already know how to do this, and just like me when I was preparing for this video, you can go up to the Help menu, click on Contents. Now we know the reservoir is a node, so we can start there by opening up the different classes and then click on Node, and then expand Node, click on Fields. Here are the different fields associated with the node. And we should probably look at this M value right here. This M node class contains all the information for a node that can be used in a model and can be edited in the graphical user interface. Now, we know from experience that if you click on the reservoir and you click on the general tab, then we can actually edit the priority number right here. So there should be a field in this M node class that can directly read and write to and from this reservoir priority field. All right, so back to the documentation. It says MN info class. So let's go to the MN info class. It's right here. Here are the fields. And this is a long list of fields associated with nodes in general, not just reservoirs, because there's also demand nodes, there's non-storage nodes, but a lot of them are pertain to reservoir nodes. All right, so we're looking for priority, and these are alphabetical. So here it is, priority field contains priorities for hydraulic states. It's for reservoir nodes only. So I think we're on to something. Let's go ahead and go back to the code now. And what I'm going to paste into the onIteration top subroutine right here is these three lines. The first is just a comment to set reservoir priorities. And the way that works is we reference the object for the reservoir dot m dot priority, and then we set it to a number, such as 90 or 100. Now, because reservoir 1 priority is set to 90, then that means it has a higher rank. It's more important to keep water in reservoir 1, and consequently, reservoir 2 is going to drain first until it's empty, and then after that, reservoir 1 will begin to drain. Just from trial and error, I realized it needs to be a long array, so that's why you're seeing the syntax is what it is here. But after that, we're ready to save and run, or I should say save, compile, and run. Save, let's go ahead and save this to my project directory. It's right here. I'm just going to call it script1.vb. Okay. File and compile. Okay, or click yes when you get that message box. I've got a message here that says it was built without errors. So it's generated an executable file for us to run. We can go up to File, Run. All right, that finished up. Let's take a look at the reservoir results now. So I'm going to close the code base, then right click on Graph. That is reservoir 1. Okay, good. I think we got it right. And then here is reservoir 2. All right, so with volume selected, reservoir 2 right here in dark orange drains first, and then after that, reservoir 1 is draining second. Okay, next what we're going to do is set the priority such that reservoir 1 drains for the first 2 years, and then after that, reservoir 2 drains after that. So this is a scenario 3. Let's go back to the code here. So MODSIM custom runs, and we don't need to change everything. We can keep what we already have in, hold on a second. I think closing it. Okay, yeah, I need to open up that file. I shouldn't have closed it. File and open. I should see my script1.vb. Okay, very cool. Good to see that was back. What we can keep is the initialization as well as the object assignment. But down here in the on iterate subroutine, I'm going to paste in some different code. Here it is. And then let me indent it now. Boom. What we're doing here is we're getting the current date from the actual simulation. If you want to see what that code is, pretty wide. Okay, there it is in its entirety. That is how to get the actual date of the simulation. And what we're going to use this for is check for the year. So the current date dot year property, which is associated with the date class, is going to be an integer. And if it's 1980 or 1981, then what we're doing is setting the priority so that reservoir 1 is going to drain first. And then after 2 years, starting in the beginning of 1982, the priorities switch, in which case reservoir 2 is going to drain after that, simply by modifying the priority of these reservoirs based on the year. Okay, so let's see if that works. I'm going to go File, Save, File, Compile, click Yes, wait for that to give us the all clear. Okay, it did. And now let's go ahead and run. All right, let's go ahead and check out those reservoir volumes. Now, all this time, I do assume that the demand has been met. So let's just check that out real quick. Here's the flow. Yep, looks good there. All right, now to what we're really interested in, the reservoir volumes. Here is a graph of reservoir 1. Okay, reservoir 2. This puts both the reservoir growth data on the same plot here. It looks like the releases from reservoir 1 are taking place for, let's see, this is the flow. This is the release from reservoir 1 for the first 2 years. Okay. And then reservoir 2 is releasing for years 3, 4, and 5, which is 1982, 83, and 84. Let's check out the volume plot. We should probably know what to expect here. All right. So reservoir 1 storage drops down because it's being utilized for the first 2 years, and then it holds steady. During that time, reservoir 2 storage in the dark orange is decreasing for those last 3 years. All right, so moving on to scenario 4. Reservoir drains at the same time, except reservoir 1 equals 80% the volume of reservoir 2. At least that's what I have in my notes. So what we're going to be doing is, instead of one reservoir draining and then the other and so on, they're going to be both draining at the same time. However, they're going to be draining at different rates. So say, for instance, we just value the water in one reservoir a little bit higher than the other, but we don't want to assign the entire demand to be satisfied by just one reservoir. Let's close up the plot and then go back to the custom code. I'm going to scroll down and change the code that we have in this on iteration top subroutine. So I'm going to select what I already have and then paste in what is on my clipboard, which is what we have prepared for scenario 4 here. And what we have is an if statement. So this start property is the property associated with the volume in the reservoir at the beginning of the time period. So if we wanted to check that out in the help, again, we know that the reservoir is a node. So let's go to our classes. Let's go to node and then the fields in the node. Instead of the M property, there's the MN info is what we want. The MN info class contains all node variables used exclusively by the model, which is not something the user can directly change, like in the user interface, as was the case with priority. So MN info is the class we're interested in now. That's right here. So let's see what fields we have to work with. And towards the bottom, there's a field for start, and that says the reservoir contents at the beginning of the time step. So what I'm pretty sure it means is the reservoir volume or the reservoir storage at the beginning of the time step in the units assigned to that reservoir. Okay. So anyway, back to what we're looking at here. If the reservoir starting storage in reservoir 1 is greater than 80% of the starting storage of volume of water in reservoir 2, then these are the priorities we're going to release from reservoir 1. And if that's not the case, these are the priorities we're going to release from reservoir 2. Okay, so that's all that's happening here. Let's go with a file and a save, and then a compile, and then a yes. Wait for that to give us the successful build message. Okay, I think it is. Let's go ahead and click on run. Okay, so that ran. Let's check out the reservoir volumes again. One other way to do this is to go to MODSIM graphing mode, click on one of the reservoirs, minimize it, click on the other reservoir, and then now we can bring up the box right here. Here is the graph. And reservoir 1 storage right here is now 80% of reservoir 2 storage, which is right here in the dark orange. All right. So we could go ahead and zoom in and actually compare numbers. So for instance, 160 is 80% of about 200,000. Yep, that makes sense. And I'll zoom back out, but we could make that comparison other places, like at the very bottom. We have 80,000 right about here is 80% of 100,000. So it's not exactly the case because it looks like only one reservoir is releasing per time period. But if we trace up, we should see a time period like right here where one reservoir is releasing twice in a row just to try to maintain that 80% threshold that we specified. So that was scenario 4. Scenarios 5 and 6 isn't going to involve the code, will involve looking at the results after modifying the model slightly. So what we're going to do for scenario 5 is add an inflow node that flows into each of these reservoirs, reservoir 1 and reservoir 2, and non-storage node. So we'll just call it, how about NS2? And then it's going to have a link to reservoir 2 and to reservoir 1. I'm going to edit the properties here. And what we're going to do is say that there's actually zero inflow for the first 3 years and then 12,000 acre feet per month of inflow from this inflow node NS2. And that's going to start on the 3rd year. So I think I have to click varies by year. And yeah, I do. Let's go ahead and do the date first. So that'll be January and then 1983. And then the flow rate, like I said, is 12,000 acre feet per month. Okay, apply and okay. So what do we expect is going to happen? The first 3 years will probably look the exact same as they did in the prior simulation. However, starting at the beginning of the 4th year, we're probably going to see a refill of these 2 reservoirs. And without changing any of the logic, that refill will probably also be consistently maintaining that 80% offset, as long as neither of the reservoirs are completely full or completely empty. All right, so I'm going to save this for sure. And then let's go back to our code. We don't need to recompile because we didn't change anything. We should just have to run and we should see some changes. All right, so that ran, and I think I still have my graphing mode on. Yep. All right, I'm going to click on reservoir 1. Okay, cool. We see some recharge. And reservoir 2. All right, very cool. And as expected, reservoir 1 storage continues down and then starts to recharge. And then reservoir 2, that is in orange right here, it starts to release after reservoir 1 is down to 80%. And then it is also rebounding with the added inflow from NS2, which begins at the beginning of the fourth year. Now, this is kind of a jagged plot, both going down and especially going back up on the recharge. And I think that's simply because if we zoom in on the plot, we're only refilling one reservoir per time period, which isn't a problem, except time periods are months, which is a long period. But if we change the time step to something smaller, then it should be a much smoother curve, both on the descent and the ascent as we drain water from the reservoir and refill it. So for this, what I'm calling sixth scenario, what I'm going to do is close the plot, go up to MODSIM network settings, and then in the time step tab, change the time step from 1 month to 1 day, apply, okay, save, and then let's go back to run the code or run this executable. All right, that finished up. And now let's check out the plots for those reservoirs. What I expect to see is basically the same thing. Yep, except it's a much smoother curve. And then here is reservoir 2. So reservoir 1 and 2, same thing as the previous scenario, except it's a much smoother plot. All right, the last scenario that I have for this video, this exercise, is to not release any water from reservoir 1 during the months of January through April. So the first 4 months of every year, what I'm going to do is make reservoir 1 a top priority, give it a priority number very low, something like, how about 10 or 20, which means it's a much higher priority than reservoir 2. And then the remaining 8 months of every year, probably going to be going back to our current prioritization of that 80% offset between reservoirs 1 and 2. Okay, so let's break out the code one more time. I'm going to be pasting in data for this on iteration top once again over what I had previously. Control V to paste. And then what we have in the top half of this function right here is the exact same thing. But what I've added is I'm getting the current date and I'm using that to evaluate the month now. And if it's at most 4, I'm setting the priority in reservoir 1 down to 20, right? So that's what we talked about, and that's what's going to happen. Let's see what the results look like. I'm going to go File, Save, File, Compile, click Yes, and then ready for a file run. Okay, this might be pretty interesting. Let's take a look at our results from Res 1. Okay, and then Reservoir 2. All right, interesting. Well, I think we're getting a little carried away with our controls here, but you can see that Reservoir 1 storage, that is the blue line, it's not releasing any water for the first 4 months of the first year, or the first 4 months of the second year, or the first 4 months of the third year. And it looks like because it peaks up above the storage of Reservoir B for the first 4 months of the fourth year, and then it goes down for the next 8 months and then up for the next 4 months. You can see that the change that we made in the priority associated with the first 4 months of every year does seem to be taking effect and influencing the storage, or rather the releases in the reservoirs for the entire simulation. However, in months 5 through 12, we don't have that inflated priority number for reservoir 1, which is right here. And that's where we have the 80% offset, where reservoir 1 is 80% of reservoir 2. All right, well, that was it for this exercise. What we did here in MODSIM was set up a network with 2 reservoirs in parallel, and we modified that reservoir storage balance by using custom code to modify the reservoir priorities.